For you.
Hi.
Thanks for coming. I
Well,
hope
thanks for having me.
Sure, it's an honor. Hope you're having a good day so far.
Yes, it's been really good. How about yours?
Good, good.
Good.
You finally nice weather here in New York. That's it took a while.
Yes, I actually live in upstate New York, which is about well, I live about 6 hours north of the city, uh, pretty much near
Okay.
the Canadian border.
Oh, that's good.
Yeah, so it's definitely starting to warm up here as well.
Oh, that yeah. Is it too different from here? It's I guess there's more snow in the winter. Other than
So
that.
where I live, there's not necessarily more snow; it's just colder.
Oh, okay.
So yeah, it's just significantly colder here, but it is. I mean, I do love it up here. It's absolutely stunning.
Yeah, there's a lot of nature upstate. True.
Yes, that there is.
The fall is beautiful. That's my favorite season here in the East Coast is the fall.
The falls and the summers in upstate are absolutely stunning. But ask me like February or March, and I'll give you a completely different opinion.
Yeah, I imagine a lot of shoveling, I guess.
Hello,
Yeah.
everyone, and
Yeah,
very nice to meet you, Dr. Boolani
Hello,
and
nice to
Jamie.
meet you too.
I'm very
yeah.
much looking forward to your talk today. Oh, sorry, I'm interrupting you,
No, no.
Katharina. Carry on.
I realized I didn't introduce you to Jamie and Serena and Victoria. Hi, guys. Meet Dr. Ali Boolani.
Nice to
Hello,
meet you,
Dr.
Doctor.
Bellani.
Hi, nice to meet you.
Welcome.
Please call me Ali.
Okay, Ali.
Ali.
Thank you, Ali.
Yeah, nice to meet you all.
Yeah, very much looking forward to this talk. It was your paper is fascinating.
Oh, thank you. It's an exploratory study, but we're actually hoping to start the large scale study on the first or in the first or second week of June. As soon as the graduates we get back, we're going to a conference in a couple of weeks. So right after we get back from the conference is when we're hoping to start the larger study.
I could tell that from looking at it, and but it was a very interesting angle that you're taking with it about. Well, actually, I don't want to get caught up in it when you're about to do a talk on it, but we could maybe ask questions later on. But definitely incredibly interesting. I'm very just I can't wait to hear more. That's all.
If
I'm
I, if
looking
I
for.
may ask a question, are you accepting any patients for this study, or have you already done the pre-selection or whatnot?
No, so we will be recruiting for this study. We're going to be, so we'll start recruiting sometimes in June. This study does require you to come in person. And since we're currently in upstate New York, that's where we'll be doing the work. But we'll be recruiting about 600 people for this study.
Yeah, that's really awesome to hear. A friend of mine suffers from chronic fatigue syndrome, and we're always on the lookout to hear what the latest and greatest is. So, yeah, looking forward to this talk. Thanks.
Yeah, I'm looking forward to it. I actually question whether we're really classifying chronic fatigue correctly. So I think hopefully some of the work that I present today might, you know, get you to think beyond just is it chronic fatigue or could it just be chronic low energy? And yeah, we're not sure. There's just chronic fatigue is such a complex issue that we can go ahead and there's people who have different biomarkers for chronic fatigue, yet they experience the same symptoms. So, we're trying to parse that out.
Yeah, it's quite the challenge. In fact, a few years ago, doctors would just laugh at patients like, "Oh yeah, you're just you're faking it." So it's nice to see also that it's being taken much more seriously.
Yeah, we're presenting our work at the CFSME conference in July at SUNY Stony Brook. And that one, I mean, it's an entire conference dedicated to chronic fatigue, and there are some brilliant, brilliant researchers who are coming to speak at that conference.
This was sending my mind off into directions of thinking about gut bacteria somehow. We're like sharing we are sharing the body with them, right? But the idea of keeping them happy like a pet to make sure they keep us happy.
Yeah, so the gut bacteria are some, and we're still trying to figure out how the gut-brain axis works. We are hoping while we're because it's gonna, when you're talking 600 people and 2 visits, I don't have enough manpower to get this data collection done for at least a year and a half to 2 years. It's going to take us about that long. So with that in mind, we're actually looking during this time, we're actually hoping to see whether we can find the theoretical mechanisms of how it is that the gut bacteria are connected with feelings of energy and fatigue uniquely. And that's something that we hope to start that once the full study is off the ground. But it's going to be
It sounds like whatever you're going to discover, it's going to be fascinating, one way or the other. I just can't see any way you're not going to just discover things that are going to be very telling.
Yeah, I mean, we initially just stumbled upon this. That's sort of what I'll talk about in my talk today, is just how we stumbled upon this and how this entire research line came from stumbling through data.
Yeah, I think we can start. That was a great pre-discussion to warm up the room. Yeah, we can slowly start. Welcome everyone to the Science Society. We are very honored to have our special guest speaker here today, Dr. Ali Boolani. And let me give you a little bit of background information so you get to know him a little bit better. Dr. Ali Boolani, he's assistant professor at Clarkson University, and he did his bachelor at the Tulane University in international relations, and later on he also did a master's in international relations focused on international politics and economics, and then he went on and did his PhD in health and human performance focused on applied physiology, and then he did the postdoc in exercise physiology at University of Georgia, and now he also teaches in the Department of Physical Therapy and Biology, and he also supervises physical therapy research. And it's an honor to have you here, and you have such an interesting background. So usually Victoria asks a couple of general questions before you start with your talk, if that's okay with you.
Yeah, that's great.
Okay, go ahead, Victoria.
All right. Thank you, Katarina. And welcome again, Ali. Science Society welcomes you. We are so happy to have you and hear about your research. As maybe an introductory question to hear a little bit more about you, in addition to your research, I'd like to ask you, if you reflect on your life, if there's a time or an experience that you can think of that was a time that really let you know that you were interested in sciences and that you felt a special connection to science.
I think for me, there wasn't really an aha moment. I just, as you can see from my academic background, it is very diverse. Actually, I've got 2 other degrees as well that are in unrelated subjects. And a lot of it is just, I'm inherently curious. And so it's just curiosity led me down this path of, I just wanted to know the answer to something. And then next thing I knew it, I'm down a rabbit hole. And now that rabbit hole is turned into trying to understand feelings of energy and fatigue as two separate moods. And yeah, I can't really say there was a moment. It was more just, ooh, I want to know the answer to this. And I think the educational background gave me the opportunity to be able to ask the questions, but also be able to figure out how to answer them.
Right. So it sounds like, yeah, the motivation of curiosity and desire to problem solve. And I hear that as a common thread in the guests who come to this room. And it's so interesting to learn about how and when people found their path. And so speaking of path, so thank you for that. Can you describe how you found, the path that led you to the research that you're doing today? And it sounds like from what you were saying earlier that may be part of your discussion today.
It is. So I was in my postdoc. I was getting a postdoc in exercise psychology, specifically focused on fatigue. And one of the things that I was always thinking of is, well, when I feel tired, I walk really weird. And I also feel like my balance is a little bit off. So why don't I go ahead and see what's done in literature on feelings of fatigue and balance control, on gait, and there wasn't really anything done on feelings of fatigue. People had fatigued muscles and such. So I wrote a theory paper that got published in 2017 on how feelings of fatigue or cognitive fatigue would end up influencing gait and balance. And I tied it to older adults because that seemed to be the most relevant of why people would care, why people who were fatigued would walk different and stand different. And then after that, a few researchers came behind that paper, and some showed that there were significant differences in um, gait and balance with changes in feelings of fatigue. Others showed that there weren't. So, obviously, with mixed results, I wanted to kind of figure out what was going on. And I had some different data sets, and I started. So, I did my postdoc under Pat O'Connor at the University of Georgia. And Pat looks at fatigue and energy as two distinct moods from a psychological perspective, but not necessarily from a psychosocial psycho perspective. So I went back and I looked at some of the biomarker data that I had, and I found that biomarkers were uniquely related to feelings of energy and feelings of fatigue. And that's kind of when I went, oh, these psychologists are onto something. Maybe feelings of energy and fatigue are two distinct moods. And so I kind of went down that path and tried to figure out whether it was feelings of energy or feelings of fatigue that changed function, and found out that they both do change function, but it's in a very unique way, which explains a lot of those mixed results. So it just kind of started down that pathway of why was I wrong, and how do I test my assumptions?
I think, well, I'm grateful that you listen to people, and I'm sure many others in here are also, because that's leading you to your research. So thank you. Um, so now this is the time that you can launch into your discussion, and the format that we usually follow is for the guest to share their research, and then that could be followed by a question and answer. However, sometimes people like to have being encouraged in their discussion by questioning. So that's entirely up to you. And for people who do come up to the stage, we'll ask that you please flash your mics so we can call on you, because sometimes we're really blessed with a large stage, and we can make sure that we get to everyone. So with that, Dr. Ali, the mic is yours. And unless you have any questions, and please enjoy the time. Thank you.
Thank you. So I am very open to being asked questions in the middle of the talk. So feel free to ask away, um, and I'll be glad to answer them. So today, what I'll do is I'll kind of talk a little bit about myself, and also, how it is that I got to this point, and what we've done, what we know about energy and fatigue, and also where we're headed, and what we hope to be the outcome. So I guess a little bit about me. I am a multidisciplinary scientist. I've got graduate training and postgraduate training in applied physiology, kinesiology, psychology, computer science, and also social sciences, and specifically in political economics. Um, and so, first thing is, when I look at fatigue, why in the world should I care about fatigue and energy? So I don't know how many people in here are clinicians or know about clinical disorders such as multiple sclerosis, Parkinson's. But one of the things that we always hear about with people with MS and Parkinson's is they have what's called dopaminergic fatigue. So that's something that we are starting to find is that in healthy populations, dopamine is actually related to feelings of energy and not feelings of fatigue. So that might change the way we prescribe, the way we treat these patients, because what we'll find later is that energy and fatigue are biologically distinct, and they also manifest themselves distinctly. And then the other thing is patients with cancer. So, approximately 70% of patients who have a diagnosis of cancer report feeling fatigued. And this is not really my work, but there is a great group out at the University of San Francisco. They're actually UCSF. And what they did was they looked at patients with cancer who reported feeling cancer fatigue. And what they discovered was that half of them reported feeling low energy, and the other half reported feeling high fatigue. So that was very interesting because what we do is when we treat cancer fatigue, it's pretty much the same way. Okay, great. You're going to do X, Y, Z. Whereas it might not be the best way to treat patients with cancer fatigue. The other thing is chronic fatigue syndrome. I know this was mentioned earlier, but chronic fatigue syndrome, we've got some patients who have mitochondrial dysfunction, others don't. Some have low dopamine levels, others don't. Some have low serotonin levels. So, those are all different biomarkers, which is why we have such a hard time getting a true biomarker of chronic fatigue syndrome because they're just all over the place. And then something else that my work finds, which I am extremely curious about, and I would love to hear people's ideas as to why this might be. And one of them is gender disparities. What we find is that women report feeling more fatigued and lower energy than men do. We don't know why. We think, we don't know if it's whether women are just more likely to admit that they feel fatigued or low energy, or whether they're, women, it's because of the microaggressions that they go through. And that sort of leads me to that last part of the disparities, and that's the racial disparities. We have some data sets that show that African Americans who live in primarily Caucasian areas report feeling lower feelings of energy and higher feelings of fatigue. However, African Americans who live in primarily African American communities don't report the same disparities compared to their white counterparts. So maybe the gender disparities and the racial disparities have to do with some sort of sociological construct that we're not looking at. Um, we don't know. And that's something that we would, I'm very, very interested in trying to figure out. And the other aspect of it is, when you look at declines in feelings of fatigue and declines in feelings of energy, increases in feelings of fatigue, they result in usually declines in performance, which increases risk for injuries. There's been some studies out of Hopkins that show that increased fatigue leads to increased musculoskeletal injuries. There's some of my work that shows that decreased feelings of energy, lead to increased falls. So those are all reasons why I think we should continue to dig down on fatigue and energy and try to figure out what in the world's really going on. Um, and then the next part of why it is how in the world did I get here? So we talked a little bit about how I thought about how feeling tired made me walk different and made me stand and had different balance. And that's when I wrote this paper that was published in Preventive Medicine. And we wrote this theory paper and we found out that, hey, the results were mixed. And that's where, it's really, to me, you can have assumptions, but you've got to constantly test your assumptions. And one of the things that I assumed when I started this work was energy was the opposite of fatigue, right? So if you're not energetic, then you're fatigued. However, if I would have listened to psychologists for a long time, even back in the 70s, were saying that energy is different from fatigue. You can be energetic and fatigued simultaneously. And they used more anthropological reasoning, and they used, factor analyses to be able to show that energy and fatigue were different. But coming from an applied physiology, applied exercise phys background, where you define fatigue as simply just, here you go, here are these biomarkers that change, and therefore you're fatigued. It's, you've got to change your mindset, and you've got to think differently, and you've got to accept that other fields do have the answers as well, and it's not just the field that you are studying. So that's something that really got me to that point of figuring out that energy and fatigue might be different. And so I take the latest definitions of energy and fatigue, which is energy is an individual's potential to perform mental and physical activity, whereas fatigue is the subjective perceptions of reduced mental or physical capacity. And I'd love to say this is my definition, but it's actually Pat O'Connor, who's at the University of Georgia. Those are his definitions. And that's sort of the definitions that we're currently working off of, because our current models support that energy is really a subjective mood state. It's a motivation to perform tasks. And then the other thing that my work is finding is that energy, when you're looking at objective measures, what we find is that whenever there's a decline in feelings of energy, there's an increase in error rates. So, for example, if we give people cognitive tasks to perform, when there's a decline in feelings of energy, they end up not changing how quickly they respond. Instead, they end up making more errors. However, when they report feeling increases in feelings of fatigue, there's no change in error rate, and instead their reaction time decreases. So now it's just taking them longer to respond, but they're not making errors. And these might seem semantics at first, but if you think about it, um, those could have real world implications. So when you look at how people move based on how they're changing the feelings of energy and fatigue, what we end up seeing is when people are fatigued, they end up guarding themselves. So they end up walking slower. They end up saying, hey, I'm tired. Maybe I should take a break. Maybe I should rest. Whereas energy, they just make more errors and are less likely to slow down. You actually see them consistently trying to correct what's going on and trying to basically change how they walk. So, what do we know so far about energy and fatigue being different? So, first thing I'm going to do is talk about the biological correlates of energy and fatigue. So, some of the things that we find is that feelings of energy, whenever you see a change in dopamine levels, you see a change in feelings of energy. You also see changes in annexin A1, which changes in feelings of energy. Peripheral mitochondrial function, really, it's SMO2. Whenever SMO2 changes, you end up seeing changes in feelings of energy. Normalized resting metabolic rate. So, this is something that my work is showing that is associated with energy. However, there is a researcher out there that did, before I published this in 2018, she published something in 2017 and tied normalized resting metabolic rate to feelings of fatigue. However, what she did was she did not account for feelings of energy. So when we went back and we reanalyzed her data, accounting for feelings of energy, what we found was that normalized resting metabolic rate was actually associated with energy and not with fatigue. But when she completely ignored the construct of energy, she was able to basically hypothesized that it was associated with energy. I'm sorry, with fatigue. So, with that being said, yes, there are two contradictory studies, but one of the things is that those studies in particular didn't account for energy. And when we went back and reanalyzed their data, what we found was that energy was the driving force of the normalized change in normalized metabolic resting metabolic rate. And then the other thing that we find, which is what got me on this Clubhouse talk in the first place, is metabolic gut microbiomes. So what we find is gut microbiomes that are associated with metabolism were the ones that were associated with feelings of energy. And if you think about what I've talked about in the, previously with peripheral mitochondrial function, SMO2 levels, right? Normalized metabolic rates, resting metabolic rates, those are all metabolic issues. So it's interesting that we even find that the gut microbiomes that are associated with metabolism of various compounds are the ones that are associated with feelings of energy. And then we go over to feelings of fatigue, and what we find is that changes in serotonin levels are associated with feelings of fatigue, changes in histamine levels. And then the other thing that we also find, there are multiple studies on this, is that whenever there's a change in TNF alpha, so whenever there's increased TNF alpha, we find an increase in feelings of fatigue. And interestingly, what we also find is that inflammatory gut microbiomes, so gut microbiomes that are associated with inflammation, are associated with feelings of fatigue. So perhaps we are onto something here. And before I go on, one of the things that I wanted to clarify is what exactly is trait and state? So, trait is someone's normal predisposition. So, for example, if I am normally an energetic person, then I would be high trait energy. But if I'm normally a low energy person, I would be low trait energy. State, on the other hand, is how I'm feeling at the moment. So even though I'm normally energetic, I went and worked out for 2 hours and now I'm feeling low energy. So in that instance, in a very short period of time, I am low energy. So that would be state energy. So when we start looking at trait and state, what we know is that trait is stable and state is not. State can change. So when we're looking at these biological correlates, when you start thinking about trait level energy and fatigue, you've got to look at things that have temporal stability, such as gut microbiome, unless obviously you are taking antibiotics or something, but usually throughout your adult lifespan, your gut microbiome stays pretty stable. And we've got multiple studies where we've measured people 1 year out. And what we found is that despite interventions of sleep, um, exercise, their trait level, energy, and fatigue did not change. So, therefore, there is temporal stability, which is how we looked at the gut microbiome and trait level, energy, and fatigue. And then the other thing is the researchers at UCSF, they looked at trait level, energy, and fatigue. And what they found was that there were unique epigenome associated with feelings of energy and fatigue that had to do with neurotransmitters of dopamine for energy and neurotransmitters of serotonin for fatigue. So clearly there's something there. And then the other thing is also how fatigue and energy manifest themselves uniquely in how we move. So one of the things, we're not the only people. There's actually another researcher that looked at she looked at a large data set, and what she found was that trait level physical energy was associated with better gait associated functional outcomes and also lower mortality in older adults. And what we find is the same thing, where what we find is increases, high trait physical energy was associated with better gait associated functional assessments. We did ours in a single group over the course of a year. And that's where we saw that temporal stability of trait energy was there over the course of the year. And secondly, their gait associated functional outcomes were also stable because of that. The other thing that we also find is declines in mental energy lead to declines in balance. Declines in feelings of energy lead to increased variance between limb gait characteristics. So what we find is that people, when they're walking, when the less energetic they feel, the more errors they make. That actually puts them at an increased risk for falls. And then the other thing is increases in fatigue lead to decreased gait initiation speed. So what we find is that individuals are now, when they start gait, they are taking a tad bit longer. There's also less variation in their gait which means that they're now slowing down. They're being a little more careful when they're walking, and they're actually, it's leading to them trying to protect themselves from falling, which is very interesting if you think about it, right? Where in one instance, when you're feeling fatigued, you're more protective, but when you're feeling low energy, you're not, and instead you just make errors. So that's something that I find to be pretty interesting. And if you look at O'Connor's work, where he's talked about the anthropological reasons for why we have these distinct moods, why energy and fatigue are distinct, it's sort of a similar anthropological reason where he said fatigue was more of a protective mechanism for us. So when we felt fatigued, it was more of a way for us to stop doing things. Whereas we felt low energy, it was our way to be less motivated to do it, which is why we had more errors and such. So it was very interesting how, all this is tying into the work that even these psychologists who look at it from an anthropological perspective are doing. So we're finding very, very interesting results here.
That reminds me of a report from, I think it was Shire Pharmaceuticals, on the error rate when taking Adderall, for example. So after certain points, the error rate increased regardless of the dosage of the drug. And that was rather interesting because they obviously use this stuff in extreme situations when you really have to be awake. So it'd be interesting to see how these definitions of fatigue and energy translate to that study.
So that's, it's interesting that you bring that up, because I'm actually, one of the things that we did was, we find that similar effect with caffeine. So caffeine is a stimulant, and what we find, which is what Adderall is as well, right? And what we find is, and this is in my work, this is Bert Jacobson's work. Bert finds that when caffeine levels get above a certain level, you actually end up making more errors. So there's some sort of, I guess, equilibrium, right? Which is where caffeine is helpful, but beyond that, you actually see a decline in motor task performance. You end up seeing increased error rates. um, so that's very interesting, where you cited that study with Adderall, because we see, this is something that's been seen in caffeine as well. And which, this is interesting because it brings me up to another point, is where we've actually looked at trait level. So how you normally feel, trait level feelings of energy and fatigue. And what we find is that individuals who are high trait mental and physical fatigue, that means you normally feel very mentally and physically fatigued, usually get the highest mood benefits of caffeine. However, individuals who are high trait physical energy, which means they normally feel physically energetic, get the best motor task performance um, of consuming caffeine. So perhaps it's even the trait level energy and fatigue is also impacting the response to caffeine. And I'd be curious to see if they looked at hyper versus hypo responders in that Adderall study that you just talked about, uh, to see whether there might be some differences. And I think that this is where the beauty of data, right? If you really dig down and look at the data, what you find is that it can tell you a lot more stories than just looking at the aggregate means.
I'll try to find the study and send in the back channel.
Oh, that would be great if you could. So that kind of brings me to another point, which is, what we find, something that I think a lot of researchers show is that, exercise increases feelings of energy. And then eventually, over a certain period of time, you start seeing a decrease in feelings of fatigue. What we found was we actually did a study. We followed these 22 individuals for a year, as I was telling you, with the trait level and functional assessment. But we put them through an exercise protocol twice a week. And what was interesting is that when we looked at acute changes in feelings of energy and fatigue, we find that there was an increase in feelings of energy, but there was no change in feelings of fatigue. So one of my uh, undergrad students who was a math major. I actually made her plot out everyone's changes. And what she found was that there were some people who were consistently reporting feeling more fatigued when we were, when we looked at pre post responses. And so when we went back and took those people out, what we found was actually exercise decreased fatigue. So apparently there's a group of people, and in our particular case, we were doing an aquatic physical therapy intervention, and this was a group exercise. And what we found was that individuals who have low social functioning, which was approximately 45% of our population, reported feeling increased feelings of physical and mental fatigue after exercise. So perhaps, not everyone's going to respond the same way to exercise as well. And then the other thing that we see, which is also very interesting, and this isn't just my work, Laura Ellingson's doing some great work with this as well, is what they find is that individuals who sit for greater than 8 hours don't get the physical activity benefits on feelings of mental energy and fatigue, but they do get the physical activity benefits on physical energy and fatigue. And this is kind of right along the lines of this whole inter-individual differences. So we have another study that hasn't been published yet. But what we find is that we make these individuals do mental tasks over the course of um, 1.5 hours. So what we did was we wanted to mimic a classroom setting. And so we made individuals do mental tasks for an hour and a half, 28 minutes of mental task with the 2-minute break. And then what we also did was we had 3 different interventions. One was a sitting desk, the other one was a standing desk, and the last one was sitting for 28 minutes. And then in the 2 minutes when we didn't give them the cognitive tasks, we had them walk for 2 minutes. And this is where results were super interesting. When we looked at it as a group, what we found is that as a group, when individuals were sitting, they reported an increase in feelings of anxiety. They reported a decrease in feelings of fatigue. They reported, increase in feelings of fatigue. They reported decreases in feelings of energy, just sort of what you would expect from sitting. Whereas if these individuals were standing, there was no significant difference. Now, when we split them up based on whether they reported feeling normally high fatigued or low fatigued or high energy or low energy, that's when the results get super interesting. Because what we find is that individuals who normally report feeling low physical energy, when they were sitting, they saw a significant spike in feelings of anxiety. And that was sort of interesting because the people who were high trait physical energy reported no change in feelings of anxiety. So, what that suggests is that people who normally don't feel energetic, if they're going to do mental tasks sitting, will see a large enough spike, and which is also what was dragging the entire group up. And then some of the other interesting findings were that individuals who normally feel physically fatigued in a standing condition and in walking, they actually felt more fatigued than when they were sitting. So if you normally feel physically fatigued, maybe sitting is a better intervention for you to not feel that physically fatigued. So those were very interesting findings for us. And some of the other interesting findings, which kind of ties back into the gut microbiota work, is recently, as of I want to say it was about a week and a half ago, we published a study where we looked at an adaptogenic rich caffeinated beverage, and we compared it to a synthetic caffeinated beverage. So we looked at a brewed caffeine versus a caffeine that was caffeinated product that was developed in the lab. And what we found was that there were unique differences in how certain people responded to this adaptogenic rich caffeine. And one of the our thoughts are we don't know if the unique impact is based on the gut microbiota or if it's based on the unique epigenetic biomarkers, because what we find is that individuals who normally felt fatigued, when they had the adaptogenic rich beverage, they actually felt significantly better. They felt less fatigue, they felt higher energy. Same
So
thing.
can you explain what that drink is, or that like what does that mean? I haven't heard that term before.
I'm sorry, what does what mean?
Adaptogenic.
So adaptogens are plant-based phytochemicals. I wouldn't say I'm an expert on the expert on them is Eric Gumpert, who is based out of Arizona. And so Eric and I did this work, and they work on adaptogens. Basically, are plant-based phytochemicals that they use. There are I want to say, don't quote me on the exact numbers. There are 12 of them or 16, somewhere in that range. And what they did was they mixed those adaptogens with caffeine, and they wanted to see if the impact on moods and cognitive task performance and fine motor task performance was different for this adaptogenic rich beverage versus a synthetic caffeine beverage. Um,
Thank you very much. I'm just taking notes here, so I appreciate the clarification. Thank you.
yeah, not a problem. So one of the things that what we've tried to do is we've tried to see if we can identify feelings of energy and fatigue and changes in feelings of energy and fatigue. And so, what we're using right now for that is a combination of computer vision as well as sensors. So, I've got a background in computer science as well. And so I use some of my computer science background to use machine learning. Right now, we're doing a study where we're trying to see whether machine learning or deep learning would be the best way to identify feelings of energy and fatigue. And what we did was we've used single task walking gait. And I know Katerina has my presentation, but it's got links to where you can see what gait differences are. So you can click on it, and we've got models that we've created in Unity, so you can see what someone who's anxious walks like versus someone who's not, someone who sleeps poorly the night before versus someone who doesn't. And so we've used human movement to try to identify feelings of energy and fatigue, and also its associated factors. Um, and so eventually, our goal is to create artificial intelligence that can identify how someone's feeling in the moment and then prescribe individualized interventions for these people. And so, with that in mind, we are looking at individualized interventions. And some of the issues that we're having is, looking at how people have previously identified feelings of energy and fatigue. And one of the things that we see is that people in the past have used ratings of perceived exertion, or RPE, to measure fatigue. We actually stopped data collection on a study because what we did was uh, we measured individuals' feelings of energy and fatigue. We put them through a 2 hour long, physically grueling exercise protocol. And then we finished that up by making them perform a Bruce Protocol VO2 max test, where we had them take their RPEs to a minimum of 17, which is what literature uses to identify as feelings of fatigue. However, this is where the results get super interesting. Half of our subjects reported feeling more energetic instead of less energetic. Half of our subjects reported feeling less fatigued instead of more fatigued. So we figured we'd stop collecting data at 12, because if things were still going to continue at this rate, there was absolutely no point in us collecting data to 30, to an N of 30, so that we can meet our initial power calculations. And so we are hoping to report that, because it seems as if we can't go back to some of that literature that uses RPE to define fatigue. So the other thing that we're also looking at is individualized interventions on our end. And some of it is we're looking at, I think something that literature does normally is, look at exercise with aerobic versus strength. But how about your relationship to exercise? Because there's so much more to exercise than just like getting on an elliptical, and what you prefer and your personal relationship to exercise. So we're actually drawing on an exercise philosopher's work. So we're looking at your philosophical definition of exercise and your philosophical relationship with exercise. And so we classify these ontological types of exercise, and we try to see how people respond. And we've done the data analysis. We're actually in the process of writing this up. And what we find is that women, when they exercise with one other person, they feel more energetic than when they exercise by themselves or exercise in a group or exercise out in nature. Men, on the other hand, they feel significantly more energetic when they exercise with multiple people rather than by themselves or with one other person or in nature. Now, we are hoping after this to start looking for inter-individual differences. But for right now, we have over 2,800 different data points that we've looked at. And then the other interesting thing that we find in this is that when women exercise with other people, whether it's with one other person or with multiple people, they report feeling less depressed. Now, granted, this data was collected during the summer of the first summer of COVID. So perhaps, during that time, they weren't social distancing, they were getting social interactions. But we found those really interesting because we didn't find the same results with men. So I'm really curious to see if people have um, ideas as to why this might be the case. And then something else that we're currently doing. So one of the things that's been done in literature, and this is something that they've looked at individual muscles and how they fatigue when people fatigue. However, what I am truly interested in is, can we identify how the network of muscles work together, right? So, how's the intermuscular coordination changing when people feel more fatigued? But then also, how is it changing when people feel less fatigued? So, one of the problems with looking at individual muscle EMGs and looking at how those muscle uh, EMG signals change is that researchers have only been able to look at how they change when people become fatigued. No one's been able to identify, well, what happens when you start to feel better? How do those signals change? And so, what we're trying to do right now is we're actually trying to identify what happens when how do those interactions change? And instead of looking at just one muscle, we're looking at interactions of 8 different muscles. And then what we want to do is see how do those interactions change once they start to feel better. So in combination to EMG, we're also using IMU signals. We're using a combination of, right now we're trying to figure out whether deep learning or machine learning will be the way to go. We are currently working with the data. We've found some places where data is dropped. One of the problems with sensors is data gets dropped. But that's sort of where we are with that. And the other thing that we're doing, which I think is also very important, is as we're starting to use VR, right? Something that, you look at Oculus and such, and, I'm not trying to call out a company here, but we are starting to do things like VR exercise. But has anyone thought about the cognitive loads that VR has on people, right? Like, how does it impact feelings of mental energy, feelings of mental fatigue? So
Could I ask a question?
yeah, definitely.
Have you integrated any studies of fMRI or PET scans looking at different anatomical areas like the cerebellum, the reticular activating system, some of the basal ganglia, in terms of these issues of uh, coordination, cognitive load, um, state of arousal or fatigue, because that might provide an orthogonal view of a lot of these questions you're asking.
We have not. I don't have access to that where I am, unfortunately. But if you know of a researcher who might be interested in asking those questions, who does have access to it, I would love to collaborate with them.
Yeah, I'd look into the neuroscience team at UC Davis in particular. Might be you might find some hotspots there.
Definitely, thank you. I'll definitely take a look at them and reach out to them. So yeah, I mean, I think that those would be very, very interesting questions for us to ask. Right now, some of the other things that we're doing is the group out at University of Connecticut, the Corey Stringer Institute. They have They have 180 biomarkers and changes in feelings of energy and fatigue. And so right now, I'm working with that group to try to see what other biomarkers change uniquely with feelings of energy and fatigue. So I just feel like there's so much more for us to learn with this.
May I? Oh,
Um,
sorry.
mhm. Go ahead.
I'm curious if you've looked into pernicious anemia and if that has anything to do with, well, intrinsic factor, obviously, but and levels of fatigue. So lack of.
We have personally not looked at it. Right now, we are primarily working with healthy adults because that is the population that I have access to. We're in a very small town, so even doing older adult work, limits the. We have a very limited number of people here who we can tap into. But as I'm starting to work with researchers at other universities, we are hoping to get more into patient populations.
All right, thank you.
You're welcome. So right now, I'm really trying to figure out what are these, how do these people respond? What are the inter and intra individual differences? We hope to create some great artificial intelligence that can help us identify when people are feeling more fatigued, and then also prescribe um, intervention. So right now we have a couple of studies that are ongoing. The first study is looking at the gut microbiome stuff that I was telling you about, the larger study. We will hope to start that in June, where we're looking at, and we're looking at collecting data on 600 people. And then the other thing that we're doing with that study is we're actually piloting some novel sensors that we have created. We've created pressure and IMU sensors that are about the thickness of a Band-Aid, and we've put them in insoles as well as sewn them in basically in a t-shirt. It's one of those Walmart t-shirts at the moment, and we've sewn them in them, and we are hoping to use those along with our current IMU sensors as well as video data, because we want to use some computer vision work as well to see if we can identify feelings of energy and fatigue on a larger scale, because our last models, and we were at 88.6% accuracy with, and those of you who are familiar with the with the terms, when you're talking about with changes in our classifier models, I mean, we had accuracy rates of uh, 85, 88% with AUC rocks above 0.9. And then in our regressor models, we had R squares of 88.6 with our MAEs being less than 0.006. So we're talking, we see that we've got very good models, and then we just seen bigger numbers. So what we're hoping to do is, with this, when we're collecting data for the gut microbiome study, we can also collect human movement data and see if we can do a better job with the larger sample size, but also see whether our unique sensors, which to me are a lot better, because the current sensor models that we use 7 sensors. But I don't know about you, I don't want to walk around with 7 sensors attached to me every day. So we're trying to create sensors that can be embedded into clothing that could identify changes in feelings of energy and fatigue. And if you think about it from a perspective of older adults, hey, an older adult, we might be able to alert them when they're at a higher risk for trips and falls, and say, maybe slow down, or maybe members of the military, hey, you're at a higher rate for making errors, or you're at a higher rate for
Time
musculoskeletal
to
injuries.
hydrate, Private. Time to hydrate.
Sorry?
I was just yelling, but all of a sudden the warfighter in the field receives an audio message that says, "Time to hydrate, Private." That would be like an automated system that would actually be very beneficial. I think my question is, what is the nature or mechanism of these sensors? Because that sounds very fascinating. Like I myself work on sensor technology, so.
Oh,
Yeah,
so this
and
is,
along the same lines, both Under Armour and the military are doing a lot of this kind of work. If you haven't plugged into those communities,
yeah, so that's really where my work is currently headed. Is being plugged into those, not specifically Under Armour, but military. So I've got a couple of grants that have, it's been, those of you who are academics know how the DoD funding works. You score really well, but it can be put in a basket. I've been put in a basket for the last two grants, and the primary reason's just been um, score certain scores. I won't get into details on a public forum, but the scientific scores have been really, really high. And so I'm hoping the collaboration with the Corey Stringer Institute, as well as a colleague at University of Indiana, changes those scores, and we're able to secure the funding needed to be able to do this work in the military.
Yeah, that's really
Well,
exciting.
one
I heard that oftentimes these institutions that grant these kinds of funds have some policies like we reject you the first four times on principle, just a low level filter. So I heard things like that that kind of made me a little bit pessimistic, but I'm still hopeful.
well,
So
well,
hopefully you get it on your next shot.
well,
I hope so
one
too.
comment to offer in terms of the IMU, the wearable IMUs,
Mhm.
in particularly if you're going after a military application. The sensor quality on the IMU is problematic. In those IMUs, you really get what you pay for. And particularly if you're going for AI classifications of subtle changes in motion, that might actually be problematic. Just just a comment. I've seen that case. I've been forced to, even on just pet projects, be forced to upgrade to higher quality IMUs to get accuracy data. So just wanted to mention that because in terms of military applications, they'd be aware of that. So just a comment there.
Thanks. I mean, the sensors that we are using are 3D printed, and the electrical engineer who I work with, he is 3D printing them. But one of the things that we're doing is working with our material scientists to make them both an IMU and a pressure sensor, because we're hoping between the two we've got enough data sensitivity to be able to classify and to be able to identify these moods. But that's one of the reasons why our project is actually going to be starting around the second week of June, is that we're currently trying to use our students as well as ourselves as guinea pigs to see what the signal quality is, um, and whether we can use that data to accurate, or at least relatively accurately classify in our just the people in our lab.
That's going to be good data to include in the application, definitely.
Yeah, so yeah, we're hopeful it's good, but right, I mean, I just literally earlier today I was the guinea pig, so I can tell you we're working on that. We're hoping it's good quality data. So that's one of the things that we're doing, and the other thing that we're also doing is one of the things that comes up and is an issue is that a lot of these sensors, especially when you're talking about walk and gait and such, they're for able-bodied individuals who can ambulate without any sort of neurological issues or anything like that. So we're talking healthy adults. But what about individuals who can't ambulate, who are para athletes, or who are, even if you look at it from the perspective of, people who are competing in esports? So one of the other things that we're also doing right now, we're partnering with a company out in Silicon Valley, and we're trying to determine whether eye movement, but we're also, in addition to that, we're looking at blink rate as well as length of time of blinking to see if we can identify changes in feelings of energy and fatigue with that data. We just started collecting data on that last week. And so we're still a ways away, but this is something that we're going to give it a shot and see if we're any good at it. So that's sort of what we're doing at the moment. And hopefully after this, we can, start to create some sort of hierarchical models to be able to um, optimize exercise or sleep or whatever it is. But I think we're ways away from that. We still have, and when it comes to sensors, right? We've looked at IMU and pressure sensors, but maybe there are better ways. Maybe there are, maybe it requires us to use some sort of near infrared sensors along with it. So we really need to have a better understanding of these biomarkers that are unique. And also, how are these biomarkers different for various populations? Are there overlapping biomarkers? One of the other things that a colleague of mine, well, my postdoc mentor, Pat O'Connor, is finding is that muscle mass plays a role in changes in intensity of feelings of energy and fatigue. So that kind of brings up the point of like, does muscle fiber type play a role? And then are there unique patterns of contraction between these muscle fiber types? What are these, and how are these inter-individual differences? And then something else that this is not my work, but there's some researchers that have looked at loneliness, and what they find is that individuals who are lonely don't get the exercise benefits of feeling when they feel fatigued. They don't get those exercise benefits. So I'm wondering, is there some sort of psychosocial component that I'm not thinking about? And then, the microaggression stuff I talked about earlier, are there maybe some social interventions that we can also look at? Um, and then the other thing is, using some of my brief behavioral economics background, is how do things like endowment effect change our reporting of these, because a lot of fatigue and energy measures are self-reported. How do these, choice architecture, deadline effect, how do these impact our self-reporting? And obviously, with technology, we've got these technological challenges. As I don't know who it is that just spoke about the IMU sensors. You've got the IMU sensors, energy and fatigue are on a spectrum, which makes it very difficult to create a ground truth. We should also probably find better signals. And then the other thing, so we did a study just simply trying to capture eye movement data. And at least with our technology, and we were simply using webcams, um, we were unable to capture data in darker skin populations. And so that's clearly something that we need to work on. And also, the stuff that's been the most accurate has also been very data intensive. So our most accurate models, I mean, we've used RGB cameras, and RGB cameras, anyone who's worked with them knows that they're very, very data intensive. So we need to find better ways to do it. But yeah, that's actually the end of my chat.
Could I just comment on your last point? Um,
Yeah.
and 23andMe has a huge database of both people and GWAS findings, and um, they routinely report out now some of the genetic markers um, of muscle function. And it might be really interesting to do, another orthogonal lens overlay of that information on the other inputs you have to the model.
That would be, yep, that would be very, very interesting.
Yeah, I immediately think of Beat Saber and John Carmack every Monday or whatever. He hosts like a battle where he invites people to come and battle him in a one-on-one session of Beat Saber. I think self-reporting in that situation, correlating that data with something like 23andMe, I know I would be willing to share that data for the sake of science. And I think 23andMe has also shown that there's a lot of people who are like-minded. You know, the joke is Bill Gates makes a vaccine. Everyone thinks he's trying to put nanotech into their body. Elon Musk comes along and says, I literally want to put a microchip inside your head. And people say, shut up and take my money. So there's this kind of bifurcation of the population. But definitely partnerships with these organizations or other things like that might be possible too, especially since you're referring to gaming platforms.
I've tried to, make that partnership with one of the larger companies, and their response, at least to me, was we have a bad reputation of collecting data, and we don't know if we want to collect mood data on people. So
They're
I'm
already
hoping that,
doing it.
Yeah,
yeah,
Facebook, like the one of the neuroscientists here, he actually had a project funded by Facebook, and it was specifically VR, and it pertained to a bunch of these kinds of various aspects of multi-sensory integration and kind of calibration of senses. And I definitely, if you'd like, perhaps their contact would be willing to discuss it with you. I think that's always a possibility. They were surprisingly very open, and to this day, I think Meta has this huge push to the metaverse, and so perhaps it's just a matter of putting a few keywords like metaverse into the grant or proposal.
yeah, that would be great if I could, and if you've got the contacts, that would be great. I think that's sort of been my biggest challenge right now.
Dr. Boolani, in terms of the computer vision component of these experiments, have you considered using thermal cameras?
I have not. I'm trying to move away from the higher spec cameras. The upcoming study, we're actually going to use our iPad Pro cameras. The We're going to use 720p cameras because we are trying to use low tech because I want this to be accessible to as many people as possible.
Understand. The only reason I brought that up was because it can um, give you some insight into their baseline rates in terms of blood flow and other things, and it might be able to provide some more insight into these resting states and the differentials that you're trying to suss out.
I hadn't thought about it that way, but I'll definitely take a look at those thermal cameras and see if they're in our lab budget or not.
Yeah, that's the biggest thing that I found. Any sort of continuous monitoring requires so much data, and if you compress, you'll lose the nuance. And so either you have to have some very quick and rapid review every day where you can look at the data, uh, kind of parse the noise, and then compress it and then throw it away. But ideally, you would want to keep track of it. And so it just becomes this, the IoT data crisis. Where do you put all this data? It just becomes ridiculous.
Have,
Yep,
have you have you spoken at all to Adam Gazzaley, the founder of Akili, or have you thought about? Are you familiar with Akili?
I am not.
Okay, Akili. I would just take a look at it and see if you find anything interesting there. I think you might.
Okay, thank you. I'll definitely. I'm actually trying to put it down in my notes right now.
Yeah, it
Uh,
might be interesting in terms of both cognitive load and fatigue, but it's a gaming tool for cognitive conditioning.
no, I am not familiar, but thank you. I'll definitely look that up.
Hi, Doctor. I wanted to jump in. I have two questions. Well, three questions. One is about muscle memory in fatigue. Um, how has that been studied, especially like when gait imbalances occur? My second question is: have you used like Oculus VR is also being used in physical therapy? There's like sensors in the insoles, and there's like a pad, and that can um, regulate and monitor like movements. Have you guys looked at that? And then lastly, if there is muscle memory in fatigue, can that be overrun? Like, can you like when you like when you get a cramp, it's very painful. Like, can there be something like that where as soon as you feel any type of like tension, you're like, okay, I am fatigued, I need to do this? Or like, is there anything like signals like that that you guys have come across? Yeah, I hope that made sense. Thank you.
Thanks. So, in terms of muscle memory, I think you're looking at motor coordination patterns, right? So right now there is a researcher at APL at Hopkins who is looking at specifically EMG of singular muscles with fatigue. And what he's finding is that the contraction rate drops dramatically, especially of the low frequency signals. Those just change dramatically when people become fatigued. That's sort of where he is right now with it. What we're doing is we're taking a slightly different approach than he is, and we're instead, and this is something where we are meeting Monday actually to go ahead and work on this. Is we're looking at the interactions of the muscles and how those motor coordination patterns change as people become more fatigued, and then also they become less fatigued. And when we were looking at that, as far as I am aware, we are the only people right now that are looking at those motor coordination patterns. If you're familiar with the group Ivanov's group out at BU, we're working with them. They use they have I guess they use physics and math techniques and physiology, and so as far as I'm aware, we would be that paper if we were able to do it well, we would be the first ones to do that. But we're still looking at the data on that, and I can't tell you one way or the other what we'll find. And then, as for your second question, in terms of using VR with physical therapy, we actually interestingly, the reason why I started looking at the Oculus is because my colleague who does chronic pain work, she was using the Oculus for an intervention. And so a lot of her subjects, she was initially trying it out on healthy young populations. A lot of her subjects, when they came out, reported feeling tired. And so she told me, oh, hey, this is what's going on with my subjects. Should we measure feelings of energy and fatigue in them pre and post? And so we actually started a tangential study, where we are using both the Oculus, but also using an an intervention with doing it on a regular computer monitor. And we've got the exact same intervention for both. And we want to see whether Oculus increases cognitive load more than the regular two-dimensional model does. And then with that, when you talk about the pressure sensors and such, so pressure sensors are used right now. So right now, with sensor technology, especially when it comes to gait measurements, pressure sensors, it's either pressure or IMU. There are quite a few people who are combining pressure and IMU sensors more in the biomedical engineering world and the PT world. And we are actually combining the two as well. And what we're looking to do, though, is we're looking to see whether we can use those to identify changes in feelings of energy and fatigue. However, something that we do find is that those lower extremity kinematics might not be enough, and we should actually look at movement in lumbar and sternum as well. So, which is why we're also creating IMU sensors that we're going to be embedding into lumbar region as well as in the sternum, because I think we'll need a combination of all four of those in order for us to have pretty accurate models, or to have accurate models.
Okay, yeah, yeah, the Oculus fatigue is, yeah, it is. It happens, just when you're using it just for fun as well. I don't know, it's like too much sensory overload, or I don't know, but yeah, it does happen. Thank you so much.
You're welcome.
Did you have any
Um,
participants drop due to being unable to cope with with using the Oculus devices?
So that one, we are currently at an N of 9, and we haven't had anyone drop yet. But yet is the key word. I have friends who do use VR in their research, and they have said that they've had pretty high dropout rates from people feeling, you know, as if they're about to puke and such. So I'm expecting it's going to happen at some point.
Because my understanding is that it tends some people just don't react well within very quick amount of exposure, and then I've also heard, this is not studies, this is just anecdotal evidence, that basically 15 minutes is kind of a delineation point. So maybe your experiments are running at what duration?
So this one in particular is running at 25-minute bouts. So they get 25-minute bouts and then they get 5 minutes of rest. And they're doing it for an hour and a half.
Interesting. Okay.
And from what I can tell you right now, just based on the N of 9, I've just been keeping an eye out on the data. Um, Boy, that is a huge change in feelings of mental energy and mental fatigue. You actually see both of them are just, by the time they're done with that hour and a half, they are drained. Because
That's just the self-reporting. There's no like objective markers for that, right?
There are. So what we're doing is, so O'Connor back in, I want to say 2005, what he found was that there were selective attention tasks that looked at accuracy versus reaction time, specifically the Bakken test. And so what we've done is we've created a game that uses the Bakken, not the Bakken, the RVIP, the Rapid Visual Input Processing task. And so it's basically just spaceships that are similar to what the RVIP task would be and what they, what O'Connor, Sholey, Kennedy use. And we've created that on the Oculus as well as on a 2D laptop. And that's what we're making them do. So we're trying to mentally fatigue them on top of them using this VR. And right now, I mean, just what we're seeing, the results are, I mean, the the effect size is really large. I don't know how much further we'll have to go. We've got an IRB for 30, but based on the effect sizes that I'm seeing, we might be able to stop at 15 and still meet our power.
Fascinating. Looking forward to that for sure. All right, who else has questions? Let's see mic flashes. I know I have some, but I would like to see if anybody else does.
Can I ask, please? So this is really interesting what you're discovering. Are you thinking then that more data, at the very least in the short term, could allow for maybe more effective workout regimes in general physical fitness and better ways to like analyze how to find the optimum sort of set up and health system for a person then like a workout regime, but this would be another thing to test and take into account then for to maximize health and even mental disposition.
That's what I think, right? So I think at the end of the day, the goal is to have an optimal routine for everyone. So as I said, with what we're looking at right now, people's relationships with exercise and whether that plays a role. I have a colleague, Jacob Meyer at Iowa State, and he's looking at various intensities. And so he's actually working with me, the master's student who's actually collecting data for the gut microbiome study. That's not his thesis, but his thesis is looking at various intensities of warm ups and how those impact performance on various tasks. And so we're kind of hoping from that we're able to determine how there are, how there's various intensities and types of exercise influence mood response. And um, that we're hoping that's the start to that personalized medicine, right, which I think is where we should be headed. Is, for you it might be 10 minutes of high intensity, but for me it might be 15 minutes of moderate intensity. I don't know. And that's something that would be very interesting.
This is very much putting me in mind of when I was at the gym and they're kind of they calibrate where you're at with your BMI and how they explained to me that your weight, and in the past you would just be checking your weight and you would just work out and then your weight would go down. But then they were saying how, muscle weight, it can be deceptive, right? Your weight could be, you could have high muscle but low fat. And the fact that this is being refined, I'm thinking of like another layer now where if they can find out your optimum with fatigue and energetic stuff, that this would actually allow you to include something that could have you walk away from each session feeling better, just actually as part of the routine and stuff like that. If I'm understanding that right, that sounds quite exciting, and it's something that could help everybody.
Yeah, so this study's been accepted, and you should look for it in Journal of Aquatic Physical Therapy over the next couple of months. We still don't have the proofs of it, but we did find that trait level energy and fatigue was associated with the intensity of the mood response of an aquatic physical therapy intervention. So, how you normally feel impacted how it is that you responded to this acute bout of exercise. There's also, we have some cross sectional data as well on how trait level energy is associated with the impact of sleep on feelings of energy and fatigue, and some other data on trait level energy and fatigue and how that impacts the effect of sedentary behavior on feelings of energy and fatigue. Um, so yeah, those, to me, those are really important because with what we find with specifically with the biomarkers, right, with what Eshrog has found at UCSF, and what I found with the neurotransmitter biomarker, with the neurotransmitter epigenome, and then my work with the gut microbiome, perhaps those neurotransmitters are different in people who are high trait and low trait. And I mean, her study had about 120 people. So to me, it was a well powered study. Um, and, what she found was that there were various differences in trait level energy and fatigue and the neurotransmitter epigenome. And that could potentially impact how much an intervention impacts you. So, yeah, I mean, I think that to me, I think is at least my personal opinion, maybe I'm just slanted because this is what I study, is that should be a very important aspect of what we should collect so that we can create these individualized responses.
Hey Ken, did you have a question? Thank you, Ali, for answering all the questions so far. Do you have a few more minutes for
Yes,
answering?
definitely.
Cool, thank you. Go
Oh
ahead,
yeah,
Ken.
thank you. I was wondering what type of I guess species of gut bacteria are associated with I guess low or high energy, or like maybe foods that might be associated with it.
So right now, I mean, our study was very exploratory. We literally looked at an N of 2020. So when you're talking about that sort of, especially with gut microbiota, right, where you've got so many of them, we've got to have bigger sample sizes. But just in terms of the various gut microbiota and first of all, let's get to the food. With the food stuff, what we basically found was that really the foods that, like processed foods such as hot dogs and such, were associated with increased feelings of fatigue or increased trait level fatigue. And then when we looked at the species of the bacteria, and once again, I think you should really take this with a grain of salt, just because, I mean, it's a very, very exploratory study. Um, is what we found was that the firmicutes were the ones that were associated with mental energy and uh, physical energy, and then the probacteria were associated with fatigue.
So it's like lactobacteria that's associated with I guess more energy from what you've studied, and I guess like the prebiotics are like fiber.
Yes.
There's been a lot of studies around increasing acidophilus to stabilize the gut microbiome, but that's unfortunately not always the issue. So I was actually curious what other markers you were looking at in the microbiome.
So, I'm not the gut microbiome expert. I've Lori Byerly, my colleague at LSU, is the gut microbiome expert, and she is the one who will be really digging down into the gut microbiome. I am more the energy and fatigue expert who thought that, hey, gut microbiota stable, trait level energy and fatigue stable. Is there a relationship? And that's how Lori and I started talking about that.
Synergy is great. It was very interesting how you're talking about the synergistic, well, the differences between caffeine and the synthetic versus the organic um, formulations, and I was thinking that generally it's probably the organic formulations were probably more effective due to the synergistic effects rather than the synthetic, and also to reinforce that idea when you were discussing how people were viewing the group exercise versus the individual exercise, the synergistic effect applies there as well.
Yeah. So with the adaptogens and with the synthetic, what's really interesting is that caffeine, the synthetic caffeine, both groups were pretty much the same. But then when we looked at the with the adaptogenic and brewed caffeine, it was really interesting where there was this dichotomy of people who normally felt horrible responded really well to this and to this brewed adaptogenic rich caffeine, but then people who didn't normally feel horrible, they didn't respond well at all, but they responded much better to regular caffeine. So honestly, I couldn't tell you why. This is where I think the gut microbiota would be very important, because I'd be curious to see whether the bacteria that are responsible for metabolism of some of these um, adaptogens might be associated with, there might be a higher quantity in people who normally feel horrible.
Thank you, Dr. Oh, sorry, you want us to call you Ali. Thank you. Now I'm seeing that we have a lot of friends on stage and people who have joined since the beginning. So I'll repeat, if you would have a question, please flash your mic so that we can call on you. So now we have Dr. Shah, Cici Rahim, and Mona, and Janelle, and Ken. Do any of you have a question or comment that you would like to offer, Ali?
So thank you so much, Ali. Unfortunately, I could not listen to the whole discussion, but for sure I will check on the PowerPoint that you just shared here. So I see that the result of your work, that's a wonderful work. And one of my question, that's about the short, chain fatty acid. And we know that, as I just noticed at the beginning, you mentioned about the cancer patient and how the gut microbial can be as a key factor actually for the cancer patient. Do you have any further information that you can share with us through that?
So I'm not the one who's done the cancer work. The cancer work is primarily the lab out of UCSF. Eshrog, I believe, is her name. Her last name is Eshrog. But she's done most of that work on cancer fatigue, and not only the epigenetic, the unique epigenome of the different neurotransmitters, but she's also done some work on gut microbiome as well. But that's their work. That's not mine.
I'll have to follow up with that. As I'm a cancer patient myself, fatigue is always such a pain in the ass, and it seems to ebb and flow, and it's hard for me to pin down when or under what circumstances it emerges, as I try to control or control for it as much as I can. So,
And sorry, I was just going to say that's where, it's so important for us to be able to figure out whether these patients are feeling fatigue or they're low energy, because that would change the treatment.
Mona, you had something to say?
Oh no, I had an unrelated question to that. I just wanted you guys to finish your thought on what you guys were talking about.
I think you're okay.
well, yeah, I have no further
Oh,
questions or comments. Sorry for please go ahead,
oh
Mona.
no, I just had a question on so like fasting and fatigue and energy. Was that also studied, or does because for some people fasting improves, you know, their energy levels, but it can cause fatigue, um, or the other way around. Has that been looked into?
I am unfamiliar with any studies that have looked at that. I am sure just because the sheer number of intermittent fasting studies that are coming out that have used, so you a lot of researchers use either the O'Connor State Trait Scale or the Profile of Mood Surveys or POMS. And I know that there have been several intermittent fasting studies that have recently been published that have used the POMS, but it's not something that I have personally looked at. I do have a very large data set, that the one that we collected for the ontological exercise types, that we are still parsing through. And we could, I mean, that's something that we'll try to take a look and see whether the quantity, and this is self-reported, unfortunately, whether the quantity and quality of the foods that were consumed over the course of the day before the ontological intervention, um, whether that impacted their feelings of energy and fatigue pre-exercise.
Thank you, Dr. Ali. I would like to interject here that this room is not endorsing fasting or intermittent fasting, that the topic is gut bacteria associated with fatigue and energy, in the interest of promoting accepted science, because when people are suffering from eating disorders, they can also be expecting that they are, or thinking that they are experiencing energy. However, since an eating disorder is a genetically linked mental illness, that it's actually erroneous fatigue, that energy levels that they are experiencing. So really important. Thank you for coming up and being in the room and asking your question. However, it's important that in the spirit of promoting factual information and best health practices, that we stick to the topic. Thank you so much.
Yeah, I wanted to add that there might be a lot of data. I mean, I know that there is a lot of data from clinics in Russia and North Europe where they used to be fasting, just being on water for even 2 weeks in mental health facilities was done quite frequently, and there is a lot of data about it. I at some point started looking into it. So yeah, if anyone is interested in looking at those data sets, what it then actually does to the body and the mental health, yeah, please look into those. Um, I don't know how good, but it's a they are very large data sets, but how they are, done by what standards is probably a lot of, like, it's messy, but there's a lot of data around fasting from those clinics.
I think it'll make for great future episodes of Science Society to invite some of those scientists of the upcoming intermittent fasting studies to see what their most recent data or whatnot says. So definitely something to keep an eye out for.
Yeah, my apologies. I was just asking a general question. Yeah, I was actually going to ask another question about HLA subtypes with the gut
Oh,
micro.
yeah, no
Yeah,
problem. It's just that
yeah.
there is so much disinformation about fasting, and eating disorders are deadly. They do kill 1 in 10 sufferers. So it's extremely important that when we're in a public forum, that we're very cautious about using supported data to discuss things such as fasting, because eating disorders take lives, and it's important that we stand up against that. So yeah, no reason to apologize. Just please leave informed. Thank you.
Although I think Katerina did post something to Tech News Around the World a few days ago about a study that talked about one of the best times to eat during the day was when you are most active. So that was an interesting study that we could perhaps talk in some future dates.
So I will say this: we have one study that we published in Nutrition and Health, where we found that people who skipped breakfast, we had people come into our lab between 10 a.m. and noon, and people who skipped breakfast reported feeling significantly more fatigued. But that was just from having them come in repeatedly into our labs for another study, and we had them self-report what they ate for dinner the night before and breakfast. And the people who reported not consuming breakfast that morning were the ones who reported feeling more fatigue, or also the intra-individual differences when days that our participants skipped breakfast, they reported feeling more fatigued when they started our intervention.
And as a side joke, maybe they were fatigued of the study as well, which sometimes happens as well. Having participated in a few clinical studies myself, it's often hard to be energetic every time you come in. So missing your breakfast probably sounds like a shitty morning, and then you have to come in and do stuff. So if you miss your breakfast, perhaps that's not the best start to a day. So missing the breakfast, definitely not a great option.
Yeah.
But honestly, in a clinical level, I mean, we should rule out other conditions as well. I mean, it doesn't go in a way of, I mean, always saying that it can be related or not related, because I don't know exactly what was the Mona's question about the HLA. But in general, reducing the inflammation can be the goal in a body. So it can, I mean, can be by the food or it can be by other approaches. It's dependent on the situation.
Yes, and I think what we've seen with inflammatory biomarkers for sure. Whenever there's an increase in TNF alpha, we do see increased feelings of fatigue. We have thought about, and we did apply to two different grants. They didn't end up getting funded, but we did look to see whether some of the foods that have been shown to have energy enhancing benefits, cocoa, adaptogenic rich beverages, whether those also had anti-inflammatory uh, effects. But unfortunately, the companies that we did apply, because this was private companies that we applied for grants with, they currently for this year do not have the budget. They did before the pandemic hit. They were interested, and then the pandemic hit and everything stopped for us in terms of human subjects work in person. And so they told us to shelve everything, and then we reached out to them this year and they were like, don't have the budget for it this year.
Yeah, something like 70% of biotech funding evaporated in the last week or two, so perhaps it'll result in some reshuffling in the future, but damn.
Yeah, they told us to
I,
reach out to them in 2023.
sorry about that. I have a question. Did you say people, like, did you categorize if people were prone to having allergies or they had a lot of allergies versus not, or do allergies in general play a big factor in, in inflammation and then also fatigue? Would be really interesting to look at, I think.
I agree. We actually eliminated people with allergies in our study, just because that was not the goal of that study. But the work that I'm currently looking at with the Corey Stringer Institute, they didn't eliminate anybody, and they did look at allergy. So that is something that we have talked about. Potentially looking at, but it's further down the line. But then again, this is, that's a very large data set that we're going to slowly parse our way through.
Yeah, it would be interesting to see if exercise and eating habits would maybe also change the allergy and inflammation states and allergy states. Like if it would help, if there's like a specific exercise regimen that would maybe help cope with like allergy seasons or things like that. Because back in time, people, like when I first had allergies and asthma as a kid, people would, like, the doctor would tell my mother that I should do a lot of exercise and swimming and stuff. So I don't know if that's still like I don't know if it was database, but or if anyone confirmed that, but it would be interesting.
Yeah, I'm not familiar with any of those studies. The data that we have with the Corey Stringer Institute was just a baseline allergy panel that they did, and then they collected blood biomarker work monthly over the course of 4 years on 270 athletes. So there's no repeated measures on any of the IG, so none of the allergy biomarkers are repeatedly collected. They're just collected at baseline.
Ferris joined the stage. Do you have time for one more question? I know we're going for an hour and a half.
Yeah, I'm good.
Thank you so much. I really appreciate your
You're
time.
welcome.
Ferris, welcome to the stage. Go ahead.
Yeah. Oh, thank you, Katerina, and thank you, Ali, for explaining to us this work. I actually just a few minutes ago came into the room, but I was going through the slides that you have up, and I just finished going through them, and I did notice from a sort of a doctor, as a clinician, the tiredness and fatigue and energy measurements and expressions, or perception of levels of energy, are so, I wouldn't even say secondary. They're like tertiary or even higher up in terms of how, in terms of being a construct, in terms of that there's so many levels below them that influence them. There's so many confounders that is so hard to pinpoint and let alone quantify, and even after that, let alone try to describe the mechanism behind it. And I know a lot of the grants are focusing on mechanistic aspects of research, and I can totally understand how difficult it must be to try to study, tiredness and fatigue and the energy levels, whether they were measured externally by some sort of semi, however well validated a tool is, or that they're just self-reported. But I was wondering if the hormone levels, the several hormone levels that do influence activity levels, metabolism, sort of cognitive activity, clarity, um, the energy levels, the muscular tone, as well as the muscular metabolism, as well as its reactivity in terms of time. I did notice that on one of your slides. Um, Whether we're talking about adrenaline, thyroid hormone, the growth hormone itself, cortisol, there's just so many, including insulin, glucagon, somatostatin. There's just so many hormones that play an important role as a group. And so if you're studying the hormones itself, it's kind of a world of itself. Then how about if you're studying all the factors that are influencing this? And I just find it really difficult to wrap my head around how you might be able to try to sort of pinpoint a not just one or two or three or 10, like a group of causal factors that might influence this, as well as try to figure out a way to increase it or decrease it, or help people that are, reporting or suffering from low levels or too high of levels, which I wouldn't expect people would suffer from that unless they're, you know, suffering from other stuff that they would usually push them to go to the doctor. Anyway, I don't want to ramble too long about this, but I was just sort of fascinated first by this work of yours, which is amazing, and I wish you the best of it, especially that you're trying to go about doing it from multiple angles. Um, but considering the complexity of what goes into influencing energy levels, and then starting from energy levels to go to those factors, I think might be really, really difficult. But potentially, maybe trying to focus on some of the aspects that are from your work are showing up as well established in terms of causal factors, any causal links that you're seeing that might be more potentially, it sort of changeable, that you can modifiable, that potentially can, you know, influence these energy levels and this feeling of tiredness the most. Maybe that might be a good way. I'm not, of course, I'm just sort of thinking out loud here. But yeah, considering the complexity of this, I'm just fascinated by what can be done. What do you think of the complexity, and how do you try to tackle it?
It's something that I think I'll spend my lifetime doing. It's a very, very, as you said, I mean, it's extremely complex, right? So if you just take dopamine, when you start looking at the hormonal levels, right, you've got to also think about epinephrine, norepinephrine. So with us, when we're looking at at least the hormones that we've been able to isolate, they've simply been based on, well, we gave them we ended up giving them, we used a histamine blocker. And when we did, we found that there was a decrease in feelings of fatigue. But, as we're examining, we've got a really large data set with the Corey Stringer Institute where they actually measured 180 different biomarkers and 270 people over the course of 12 months for 4 years. So that is something that we are really hoping to spend time exploring and going through and figuring out what those complex interactions are and how it is that those might impact feelings of energy and fatigue. But when you talk about interventions improve them, right? So one of the things that we have found is that AVO2, so SpO2, skeletal mitochondrial function. When we see an increase in SpO2, we end up seeing basically an increase in feelings of energy. So one of our thoughts is potentially improving mitochondrial function and increasing the density and the number of mitochondria. So something that we got, we applied for a pilot grant. We got funding for it, but unfortunately the pandemic hit, so it got accepted. Pandemic hit, and then that project never really got off the ground. But we're hoping to get it up and going. Is we wanted to see whether exercises that used both lower and upper extremities. So we were specifically interested in using the bikes that have both the arms and the legs versus the bikes that just have you pedal. And we wanted to see whether really increasing mitochondrial density in both upper density and number, and whether increasing in both upper and lower extremities versus just lower extremities, if that would change how someone feels better over time or trait level feelings of energy and fatigue. We got funded for a 12-week grant by the American Physical Therapy Association. But unfortunately, as I said, the pandemic hit, and the co-PI on that grant, he's had some things where he has been unable to actually follow through, and we've not been able to restart that study. Or shouldn't say restart, but start that study, because it got accepted literally at the end of February and things shut down in March.
Yeah, some in-person studies are still restricted at the university, so it's quite difficult to do clinical work, especially within the field of psychology, or any participants for that matter. So post-pandemic, different world indeed.
Yes, I mean, one of our studies, that the one that we're using EMG to identify both increases and decreases in feelings of energy and fatigue, using EMG work and the muscle interaction, all of our participants had to complete the data collection with the mask. And I really wonder whether it changed their self-reporting, um, and whether it impacted even their perception ratings of perceived exertion and such, on the exercise protocols. So I'm very, very interested to see if that's what happened.
Yeah,
Awesome.
thank
Anyone else have
oh,
questions? Ken or Janelle? All righty.
cool. Thank you so much
I'm okay.
for taking such a long time and patience to answer to all of our questions. And it was a really great talk, and it's really interesting and very important work. So I hope work after COVID now becomes easier, less hurdles, and we wish you a lot of funding because it's really important what you're doing. And we are really looking forward to follow your work. And whenever you have updates, please come back and share them with us anytime. And yeah, we wish you all the best. A lot of funding and the least bureaucratic hurdles there could be.
Yeah. Thank you very
Thank you.
much, Ali. Thank you so much.
You're welcome. Well, thank you very much for having me. I enjoyed it. It was great to have all these questions and the number of incredibly smart people on this call who gave me ideas of things that I hadn't even thought of. So I really appreciate that.
Yeah, it's the reason why all of us keep coming back here. Not only is it very addictive, so it's quite a challenge for impulse control, but because of the benefit every time you have a chance of bumping into somebody who just happens to say that one thing that was missing on your, in your master plan or whatever it is, your strategy that you're going for. And even just hearing your talk today, I thought, oh, well, there's this person that I know who's doing this work. I should connect you to. And, oh, well, there's actually this other person that I know. And, well, it might as well be a router if I know these people. So it's a very vibrant community. People do try to be promoting of these network effects that you often hear people like Peter Thiel talk about. So thanks once again from me as well for coming by and sharing your time with us.
Well, thank you for having me, and I'll look forward to. I'll actually look forward to dropping into this room. I'm not a big social media person, but I think I'll have to put this Clubhouse app and the Science Society Clubhouse meeting on my phone and keep it on there and drop by.
Well, you're already the perfect guest because this was the perfect lead to announcing the next room, Sally. So you're already the perfect moderator. So, yeah, thank you everyone for asking these great questions. And if you like rooms like this, please come back. We'll have tomorrow at 1 p.m. EST, Dr. Gabeline. He will be joining us from Europe, and he achieved something quite remarkable, mitochondria transplantation between living cells. It's really one of the key points for the next step in rejuvenation. So we are really looking forward to having him. Then we'll have Dr. Uyin, building complexity in biological design spaces. He is at the CUNY here in New York and nano engineering department, and he will talk about his interesting work. On Friday at 1 p.m. EST, we'll have uh, a room about dogs. Whoever loves dogs should come. It's a study about how dogs recognize dog and human emotion. It's not very common that species recognize emotions of other species, so it's quite remarkable how well dogs do this, and this is a study about that. And then on Saturday we'll have Dr. Cheryl Cheng. She will talk about using molecular orbital based machine learning. And we'll have a lot of great guest speakers, and please come back if you like these discussions. And again, a very special thanks to you, Ali. It was a wonderful talk, and we had a great time. Thank you again.
Thanks for having me. All right.
Thank you very much, Ali.
Thanks.
Welcome.
5,
Have a great night.
3,
Thank you.
2, 1.
Good night,
Bye.
everyone.
Bye.